So what we're going to have a look at here is how to do VCA exam 1, questions 1 and 2, where they essentially are asking us to apply the product rule, chain rule, or quotient rule in order to find the derivative of some function. You'll notice that this here will be on your cheat sheet. It gives you all the product rule, quotient rule, and chain rule. So we're using that throughout these, and we'll be identifying which one we need to use and what procedure we need to follow in order to solve the questions. So question 1 here asks us to differentiate x times log ex with respect to x. So the first thing I notice is that we have two functions multiplied together, first function being x and the second function being log e of x. So the first thing I'm going to do is I'm going to write those down. So the first one we're going to call u. The first function is x, and then what we need to do is we need to find the derivative of u with respect to x. The derivative of x with respect to x is 1, and the second function is v equals log base ex. Derivative of log base ex with respect to x is 1 on x, and you can have a look at that on your cheat sheet if you need to. So following the product rule here, it says that if we have two functions multiplied together and we need to find the derivative, u times v, well the derivative is given by u times the derivative of v with respect to x plus v times the derivative of u with respect to x. So it's u times dv dx, so that times that, plus log ex times 1. So that would give us f dash x, which is our derivative function, is equal to x times 1 on x, well that would just be x over x, plus 1 times log e of x, well that's log ex. If we simplify that, we can see that x divided by x is always going to be 1, because any number divided by itself is 1, and x represents some number, plus log e of x, and that would be your final answer there, and you get your full marks. The only thing you have to check is whether they want you to substitute in a value for x, but in this question here they haven't asked us to substitute in any value. If we move down to this question here, b, it says we have some function f of x is equal to cos x divided by 2x plus 2, and it wants us to find f dash of pi. So once we've found the derived function, we substitute in pi. Alright, so what I can see here is that we have two functions divided by one another, which means, we have to use the quotient rule, which is this one here, which says if we have two functions divided by one another, u divided by v, we have to follow this formula here, which says it's the derivative. It's v times the derivative of u with respect to x minus u times the derivative of v with respect to x, all divided by v squared. So again, we set up our product quotient rule, writing down all the terms. So u is going to be cos x. The order is important for the quotient rule, by the way. So du dx, derivative of cos x, derivative of sine is cos, and the derivative of cos is negative sine x. That's also on your cheat sheet. The v is going to be 2x plus 2, because that's on the bottom. And the derivative of v with respect to x is going to be 2x. Well, the constant term is going to disappear, and 2x differentiated just gives us 2, because the variable disappears. Alright, then we need to use the product rule, the quotient rule here rather. So it's v du dx, so f dash x is equal to v du dx. Well, let's write that. So v is 2x plus 2. V times du dx times minus sine of x. We're going to divide all of that. So we've got to keep going. First of all, we've got to subtract u dv dx. So u is cos x, and dv dx is 2, so that's minus 2 cos x. All that needs to be divided by 2x plus 2 squared, because 2x plus 2 is our v term. Alright. If we can write this just a little bit more nicely, we can put that negative here into each of these terms. So it's minus 2x minus 2 times sine of x minus 2 cos of x. Not a massively essential step, but write it nevertheless. And we'll just leave that as is because we're going to be substituting in a number anyway, so it's not too much of a worry. What we need to do now is substitute in, if my pen will work, it's half working. There we go, so we need to substitute in f dash of pi. So where have we seen x? We just got to put in a pi now. So it's minus 2. So it's minus 2 pi. Oops, minus 2 times pi minus 2 times sine of pi times sine of pi minus 2 cos of pi. All divided by 2 pi plus 2 all squared. Simplifying this down gives us, well, minus 2 pi minus 2. We'll think about that in a second. Well, what's sine of pi? Sine of pi, well, sine is our y values on a unit circle. Pi is halfway around the circle, so that's going to be 0. So this whole term's going to go to 0. Cos of pi is minus 1. Minus 2 times minus 1 will give us positive 2 on the top. Divided by 2 pi plus 2 squared. Alright, next question. Let's see if we can work this out. The section says f of x equals sine squared x squared. Find f dash x. Just so everyone's clear, sine squared x squared is the same thing as sine of x squared all squared. So when I look at that, what it looks like to me is we're definitely going to have to use the chain rule because we have a function inside a function. So another way of saying that is we have sine x squared all inside a larger function, being the outside, which is this squared, extra squared term. But then inside that we have another chain rule. So this here is going to be double chain rule. Because sine of x is its own function and x squared is a separate function. So that sits within itself. And then on the outside we have another function. So it'll make a bit of sense when we do it, hopefully. So let's set things up as usual for the larger outer chain rule. So we're going to say u equals sine of x squared du dx equals, well, now the question becomes how do we differentiate this with respect to x? And this is a slightly different question, and this is the other part of the chain rule, so I'll do this in green. So we need to work out what sine of x squared is. So the inside function in this case is u equals x squared. Du dx is 2x. When we're using the chain rule, we write y. Y is equal to sine of u, aka our whole function is sine of x squared, so sine of u. And the derivative of y with respect to u, well, the derivative of sine is cos, so derivative of sine is cos u. Alright, we know that the chain rule says to find dy dx is equal to du dx times dy du. Applying that in this case means it's this multiplied by this. So that will give us du dx is 2x times dy dx, which is cos of u. So that's 2x times cos, or u is x squared. So hopefully you can see how we have to use the chain rule twice here, just so that we could get to this part, to this answer, which is the derivative of sine of x squared. So we know that this here, du dx, is 2x cos x squared. All right. Now, let's use the chain rule again. So now we know y is equal to is equal to u squared. Because u is equal to sine of x squared, and what this function says is that we're squaring that whole thing. So then dy du is equal to 2u. Alright, again, our chain rule says now that it's dy dx is equal to du dx times dy du. Applying that for the color in blue here, du dx is 2x cos x squared, so 2x cos x squared times 2u. 2 and u is sine of x squared. So that there is our full answer, and hopefully you can see that we have to use the chain rule twice. Moving on to the next question here. It says, let f of x equal e to the power of 2x minus 3 all to the power of 4. Okay, let's see if we can evaluate that. Again, this looks to me like it's going to be a double chain rule question. So let's see if we can go through that. So again, we always usually start with a u. So u is our inner function, which is e to the power of 2x minus 3. Du dx, well, what we know from our cheat sheet is that the derivative of e to the ax equals ae to the ax. And this is because, and you would find this from using the chain rule on the function e to the ax. But take my word for it, and have a look at the cheat sheet if you're still unsure. So derivative of u with respect to x, well, the constant term is going to disappear, so that minus 3 is going to go. And then e to the power of 2x differentiated, following this rule here, is going to be 2e to the 2x. Okay, then the outer function, the whole thing, would be u to the power of 4. Because u is the inner part, so it's e to the 2x minus 3, and then we're raising all that to the power of 4. So then we're going to say dy du rather, is, well, the power comes down the front, so it's 4u, and then we make it smaller. Then we make the power 1 less. So I just want to make sure that's clear. That's a 2, looks like a 1. Alright, again, so dy dx is equal to du dx times dy du. So following this process, it's going to be du dx is 2e to the 2x times 4 times u, which is e to the 2x minus 3, all cubed. Alright, so that's f dash x. Question didn't ask for f dash x, it wanted for f dash of 0, so we can't forget to substitute that in. So what we get now is, substitute a 0 wherever I see an x, so it's 2e to the power of 2 times 0 times 4 e to the power of 2 times 0 minus 3 all cubed. E to the power, so 2 times e to the power of 2 times 0, so that's e to the power of 0. E to the power of 0 is 1. Anything to the power of 0 is 1, I should say. So this part here is just 2 times 4 lots of e to the power of 0 again. It'll be 1 minus 3 cubed. Alright, now these are just numbers, and we just have to crunch them. So it's 1 minus 3 is negative 2 cubed is negative 8, so it's 4 times negative 8. Never be afraid to write too many steps. 4 times negative 8 is negative 32 times 2 is negative 64. So that's our final answer there for f dash of 0. Looking at this next question here, we've got y equals sine of 2x on e to the power of 2x. Hopefully now we're starting to recognize it looks like here we've got a quotient rule question. So as usual, we set up the u is always going to come first. So u is on top in this case, so it's sine of 2x. du dx, well, let's see. If we don't know the shortcut for this, let's work it out. So we can do this the chain rule way. So I'm just going to set this up. So we have some function y equals sine of 2x. And this is how you would work out the derivative. So you say u equals 2x, du dx equals 2, y equals sine of u, dy du is equal to derivative of sine is cos, so it's cos u. Applying the chain rule says dy dx equals du dx times dy du. Applying that to that question would give us du dx, which is 2, times cos of u. 2 cos of u being 2x. So put a box around that. So we know that the derivative of sine of 2x is 2 cos 2x. And we know that from the chain rule, but it's also on your cheat sheet if you're unsure. So the next part is our v function, which is our e to the x. And the amazing thing about e to the x is that its derivative is itself. So the derivative of v in this case with respect to x is just going to be e to the x. Alright, now we have to follow the chain rule. And remember that we have to follow the quotient rule. And the quotient rule says the following: dy dx is equal to v times du dx minus u times dv dx divided by v squared. Okay, so v times du dx. So v times du dx would be e to the x times 2 cos 2x. So we could write that 2 e to the x cos 2x. Minus u dv dx. Well, u is sine 2x and dv dx is e to the x, so let's write e to the x sine 2x. All divided by v squared. E to the power of x all squared is the same thing as e to the power of 2x. If we remember our index laws. Our index laws, remember, say if I have some number a to the power of b c to the power of c, it's equal to a b to the power of c. So, is there any way that we can simplify this? Well, it looks to me as though we can take a factor of e to the x out from the top. So it would be e to the x 2 cos 2x minus sine 2x all over e to the power of 2x. Or just for convenience, I'm just going to write e to the power of 2x. Sorry, I'm going to write, just to make it clear, e to the power of x times e to the power of x. So hopefully now you can see that that e to the x can cancel with that e to the x. And our final answer will be 2 cos 2x minus sine 2x. Oops. Minus sine 2x. All divided by e to the power of x. Alright, last couple of questions. This question asks, if f of x equals e to the power of the square root of x, find f dash of 16. Hopefully it works out to be a nice number. What I think when I look at this is that it looks like a chain rule question because we have a function within a function. So let's see if we can break it down. Usually we're going to start off with writing u. U we're going to say is e. My apologies. We're going to say e is the square root of x. which is the same thing, hopefully we can remember, as x to the power of a fractional power, and that fractional power is a half. Yep, next step we've got to do is find du dx, so the derivative of u with respect to x. That's going to be, well, the power comes out the front, so it's a half x to the power of a half minus 1. Well, that's minus a half. One way we can write that a bit nicer would be 1 over 2 times the square root of x. The reason that is because this negative here makes it the reciprocal, so it becomes 1 over 2 times the square root of x, and the square root goes onto the bottom because it's negative a half. Okay, using the chain rule, we know y is our whole function is e to the power of u. We know dy du then is equal to e to the power of u, because that's the awesome thing about the exponential function. The derivative is itself. Then we just have to apply the chain rule, which we'll write out again, is dy dx equals du dx times dy du, which equals, well, du dx is 1 over 2 root x times e to the power of u, which is root x. Good, so there's our derivative function, so that's f dash x. Alright, so now we need to work out f dash of 16, and it looks like it'll hopefully work out okay. So 1 over 2 times the square root of 16 times e to the square root of 16. And my pen's not working. There we go. E equals 1 over 2 times the square root of 16 is 2 times 4, which is 8. 1 over 8 times e to the power of 4. If we want to write it nice and neatly, e to the power of 4 over 8, because we just multiply that into the numerator. And that's that question done. Get you some more 2 marks. Alright, next one here. Again, looks like a chain rule question. You can see that pops up quite a lot. So, again, we write u as our inner function, which is sine of 2x plus 1. Derivative of u, the derivative of that with respect to x is going to be, hopefully we can recall from before, if we have the derivative of sine of ax, or 2x in this case, the 2 comes out the front, so it's the derivative of the inside. So the derivative of 2x is 2 comes out the front. And then we're left with the derivative of sine is cos, so the derivative is 2 times cos 2x. And that's just the shortcut for the chain rule there. We could step each thing out if we really wanted to. And the constant term obviously goes away, so that's gone. What about this next part? So we've got y is equal to u squared. So dy du equals 2u. Alright, so now we can say, again, chain rule, dy dx is equal to du dx times dy du. We have both of these pieces of information. So du dx is 2 cos 2x. And dy du is 2u. And so that's 2 times sine of 2x plus 1. Oops, bracket there. 2x plus 1. That's the f dash x. That's the derivative function, but we want to know the derivative function at pi on 2. So it's 2, let's substitute it in, 2 cos 2 times pi on 2. Oops, pi on 2 times 2 times sine, make sure the bracket's there, 2 times sine of 2 times pi on 2. Plus 1. Alright, so see if we can work this out. 2 times cos of 2 times pi on 2. Well, let's just focus on the inside bit here. So this 2 would just get multiplied in, so to be 2 pi on 2 would just be, which would just be pi. So this part here can be helpful to do it like this, different pen. Cos of pi is -1. So this first part will be 2 times -1, which is -2. Times, all right, let's see if we can work out what this part becomes. So it's sine of 2 pi on 2. Sine of 2 pi on 2 is sine of pi. So this part here goes to 0, because remember, sine is our y values on the unit circle. If we have a look at our unit circle, pi is over here. And this is at the point -1, 0. -1, 0, so the sine value there is 0. If we go around like that, there we go. So that's 0. So now we can hopefully finish this off. So it's 2 times 0 plus 1. Well, 0 plus 1 is just 1. So it's -2 times 2, which is -4. Last question. This one here looks a bit like the product rule, because we have this function here, which is x squared minus 2x times e to the x. So usually the first step is going to be u, so let's write that down. So it's going to be x squared minus 2x. It's a terrible x squared. Squared minus 2x. Du dx. Derivative of that with respect to x, well, we focus on each term here individually, so the 2 comes out, 2x minus, well, the derivative of 2x is just 2, so that the derivative of x squared minus 2x is 2x minus 2. And what's next? So v is equal to e to the x. The derivative of v with respect to x is equal to e to the power of x. All right. Product rule says dy dx, so the derivative function is equal to u times dv dx plus v times du dx. So it's this times this plus that times that. So u dv dx, that's supposed to be a u. There we go. So that will be x line to right, that'll be good. So it'll be got x squared minus 2x times e to the power of x plus v du dx. Well, that's 2x minus 2 times e to the power of x. So that's dy dx is the format they want it in. So dy dx equals that. Is there anything we can take out? We can take out e to the power of x as a factor if we want. Maybe it'll make things a bit nicer. Let's find out. So we'll get e to the power of x out the front, and then we'll be left with x squared minus 2x plus 2x minus 2. Now, yep, that seems perfectly okay. So we've got e to the power of x minus 2x plus 2x goes to 0, so that'll be x squared minus 2. And that should be our final answer there. And that's it. Good stuff.